Hi, this is Kelly Williams, NIMSO for the 64th. I've had some other operators asking about settings with the Infinity Analyze software as far as calibrating the micrometer and some good practices for taking images, so I figured I'll make this tutorial. So I'm going to go over how to calibrate the digital micrometer in the software side. I'm not talking about the eyepiece calibrations. Then we're going to look at how to establish presets for each of the magnifications, and then some of my personal best practices for doing micro images. Here I have the Infinity Analyze software open, and I have my micrometer scale slide that's placed on there. Right now I'm at 10x magnification, the 10x objective, and I'm going to go through first setting up the preset and then establishing a calibration for the micrometer for this preset. So first I'll take the image into focus, generally as best as I can. Alright, the presets are established here in the capture control area. So first we'll add a preset and call it 10x. And that alone didn't do anything but take all the settings that I currently have here in the imaging control section and apply those settings to this preset. And right now, if I was to capture an image and measure point to point, which we know this is 100 micrometers, it may or may not be accurate. So it's pretty close, which is good. But what I'm going to do is I'm going to set the calibrate option, which can only be done on a captured image. You can't do it in the live preview. So I'm going to calibrate, go from here to here. And this is 10x magnification, and this is 1, 2, 3, 4, 5, 6, 7, 800 micrometers. And so now I want to go back and measure point to point. It should be right at 800, which you can't see there. So this should be 700. Very close. So that's good. And then once we do that calibration, it won't save unless we go to update. And now this calibration will be applied to the 10x preset. So now I'm going to switch over to a different objective. So this is my 20x objective, and if I was to capture here, and it's under the 10x preset, if I try to measure point to point, it's incorrect, right? It's off by a factor of 2 essentially. So what I'm going to do is not save that. I'm going to add a new preset called 20x. And let's say I wanted to adjust the exposure a little bit, for this particular preset. That change in camera control options will also be applied to this preset. So update with those options, and then I'm going to capture an image. Going to calibrate the micrometer. So this should be 400. So now when I go back to measure, it should be correct. There we go. I recommend trying to calibrate to as wide of a distance as you can to minimize your error. So now that we calibrated there, we'll update, and that will save to the 20x preset. Now we'll go on to the 100x, and the only difference there is you need to make sure to put your oil immersion on the micrometer scale. This is my 100x objective with oil immersion, and I focused it about as best I can here. You'll notice that it's pretty dark, so I'm going to try to bring up the brightness on that. Alright, that's good enough. So I'm going to create a new preset. And since I created the preset after making the adjustments to the image controls, all the brightness and exposure times and everything will already be applied to that. So I will capture this image, calibrate, so this is kind of an odd one, so I know this is going to be 80. Let me go back to measure. It will be correct. Great. So we'll make sure to update, or else it will not save that calibration. And that's it. So, as far as some good best practices, in my mind, when capturing some of these microscopy images, is to always have a sample description as far as text about, if it's a pat round or if it's a real world, describing it like that. So when you go back and look at the images, it will be very clear, kind of like a sample description in your lab notebook. The conditions during image capture could be if you fixed it in a different way, or if you had some special thing about that sample, like what objective it was viewed under, or what stain it was taken with, something like that. Potentially, you could have the stain and the wavelength that you were looking at be one option. Special characteristics, if you're trying to annotate something about that image that made you want to take that picture, you may want to highlight that, so when you go back to it, it doesn't look like just a general picture of the sample. You'd be drawing attention to a very special characteristic. You could use arrows or boxes or circles to highlight that if you need. I like to measure the endospores, or put a measurement of the animal cell, or if it's a fiber or a piece of plant material, you can do that point-to-point measurement on it. And then I always like to include a micrometer scale. I can show you some of that real quick. So we've done the point-to-point, like if this was a fiber or something like that, you could put the length on it. For things that tend to be round or spherical, you can do circle from 3 points, which is great. Like, let's say that this is the actual object and this is just the ring around it. You could do 3 points and it'll give you the diameter. Sometimes it will also show you the radius and the diameter, and you can go into measure options and deselect the radius if you only want the diameter when using the circle from 3 points option. It's helpful to have 1 or 2 decimal places for objects that will be less than a micrometer. So it's pretty helpful. You could also measure point to point to show that diameter, but it may not be as accurate and it may not be as descriptive as you would like. So those are really the only measurements I use. You could use angle if you're doing PLM to show angles of the crystals that you were seeing, but that's about it. So text, let's say this happened to be my FPAT. And let's say this was taken with DAPI, and it was at 100x. And then I would put a micrometer scale down here. My micrometer scale right now happens to be a little messed up. Where there's a space here, if someone knows how to fix that, then please contact me. But you can go in and edit the properties of that if you wanted it to be, say, white, so that it would pop on the background a little bit more. You can do that. I wanted to show you some examples of images that I've taken, just to illustrate some of the points that I was making about labeling as far as what I consider to be best practices. Here you can see that I described the sample and some of the conditions that this image was taken at, and in this case I heat fixed the sample and then used immersion oil as a mounting media before laying the cover slip on the Instafloor combo slides. So there was a slight variation from what I had been doing, so I annotated that. And then you can see I measured the width and length of the sample, of the objects in the sample, and labeled it with a micrometer scale. It's good, I think, to use a micrometer scale that applies to some of the dimensions that you're looking at. So I wouldn't want to put a 10 micrometer scale on here because nothing is on that order of magnitude for size. Again, here just labeling what I consider to be representative dimensions, since these are ovoids, not using the 3 points or circle from 3 points technique, but measuring length and width. So nothing particular to highlight here, except that this is a general representative look at this sample under propydium iodide. You can also see that I used the label of Y-green here to show that I was using that wavelength light. Same thing under DAPI. So this is an example of kind of a unique circumstance that I wanted to highlight in the picture, where I heat fixed this sample and then there was still some moisture in the sample as I was observing it, and it was kind of a amorphous edge like you see here, and then as it was drying it was crystallizing, and so I wanted to try to capture that, and that's why I took this picture. Without labeling this, I might not know why I would have taken this, but after learning more about the sample, it makes sense that it was crystallizing on drying. This is an example of the circle from 3 points annotations to show general measurements of objects in this Cyto BC image and representative micrometer scale. I also think it's good to not take your sample information summaries from a single image. I think it's good to make several preparations from the same sample, and then really look at it in a lot of different ways to make sure that when you report about that sample that it is actually representative. So this was kind of an odd thing in the image or in the sample, so I made sure to take a picture of that and put some measurements on it. Not representative of what's in the sample, but it was kind of interesting. Again, same thing with this. With objects that are thick, you'll notice that as you're trying to get a good image, or a good focus on the image to take that screen capture, sometimes you'll have a difficult time getting a good amount of what you consider to be that object in focus. So you can actually piece together several different images to represent one image that's in focus, kind of like doing confocal imaging, if you've never seen that. But for our purposes, just trying to get in focus what you think is the most important aspect of that object, and then taking the image off that. Yeah, that's about it. If you have any other specific questions, I can get the answer and make a video for you if you like. Thanks.